Good morning, good afternoon, and good evening, depending on where you are all joining in from. We are very, very excited to talk to you today about introduction to microservices. First of all, Happy New Year. And hi, Vivek. How are you doing today? You're on mute. All right, so you're on mute again. Um, yeah, now we can hear you.
Yeah, so Happy New Year, Nish, and whoever has joined in, Happy New Year to you too, and whoever is going to watch this, I know later on, Happy New Year.
All right. I work on the .NET community team, and I specifically focus on architectural reference guides, which includes microservices, cloud native apps, modernizing your application from, let's say, .NET Framework to .NET Core, or even taking a monolithic applications to the cloud on Azure. So there are a lot of amazing guidances out there on .NET/architecture. So don't forget to check that out. That's what I do at Microsoft. So Vivek, just introduce yourself. What do you do?
Hey, I'm a senior cloud advocate, and I'm part of the cloud and AI engineering team. I'm a technophile. I love enjoying the learning new technologies, and I'm passionate about DevOps. And basically, I also enjoy traveling. So that's about me. And hey, Nish, why don't you introduce the moderator?
Fantastic. Yes, I was about to do that. So say hi to our good, amazing moderator today, who's Swaminathan Vetri. He is a cloud solution architect at Maersk and also a Microsoft MVP. So have your questions ready, pop it into the chat, and Swami will be answering most of it, and he'll also bring it us, and we will be able to take up some questions as well. So Vivek, what are we going to learn today?
So we have two Learn modules, and just in case if you don't know about Learn Live, it's about understand learning new technologies, new concepts with Microsoft Learn. And today we are going to cover two Learn modules. And the first part of the session we will focus on one of the Learn module, which is based on how do you build microservices and what is microservices in fact, and also how do you build a microservice app with .NET. And the second part of the session, and which is the second Learn module, is basically focused on building and deploying the microservice app to Kubernetes. So these are two links which is out there. You can go back and work with us as well. If you have the sliders of the setup with you, you can take these links and build with us. Else you can sit back, enjoy the session, and then we can then you can take these modules later stage and then build on top of that.
Right. And also, I wanted to bring this to your attention that this is going to be the first in the series of microservices. We have 8 sessions lined up for you. So don't forget to tune in every Tuesday to check up on the microservices topics. Some of the topics will go slightly more in depth into cloud native technologies like resiliencies and service meshes and things like that. But this one today, we will focus very much on the cloud native tools like Dockers and Kubernetes and things like that. All right, let me just emphasize on what are we going to learn today. The important things to learn today is we will generally look at what microservices are, like what's this buzz all about and why is it important to us right now. And we'll also look at the technologies involved in it, that is cloud native related ones like Docker, Kubernetes, and things like that. And also build a microservice endpoint in .NET. So that's when you start with creating a REST endpoint, how do you containerize it, and then in the later, the module 2 will focus on Kubernetes, as Vivek mentioned. All right. So yeah, this is a live and interactive session. So you can see us all doing everything hands-on here. So any mistakes that we make here, you will see us how we will recover and make it better. So feel free to ask questions, join with us, and yeah, Vivek, anything else you want to add on this?
Yeah, I mean, we are live, and please ask questions, keep going, and we have a wonderful moderator who is taking care of the questions as well, and we will also answer the questions while we are running through this session. And obviously, because of the time, we might not pick all the questions here live, but we have a subject matter expert who is at the back end, who's answering all the questions for you.
Right. So let's get started with building the first microservice with .NET. So let's start with what are microservices. So microservices are the microservices architecture. Is nothing but an architectural pattern which states that your application is composed of multiple smaller services that focuses on a specific business functionality managed by smaller teams. And that is a key thing. It's not about taking your project and breaking that down into smaller web API or REST projects. It's not that. It's about identifying a business domain, creating a business boundary, and then creating building services from there on. So people use domain-driven design often for identifying these business problems and understanding the business boundary and defining it that way. So for today, we will not be looking in depth of that, but we will all just look at how do we start with creating an endpoint for microservices and go on from there on, right? So to speak further, a few characteristics that make up a microservices architecture, and we'll look into that. One of the important thing is microservices are small and they're independent and loosely coupled. Now, there's often questions that come up like, how small should a microservice be? The important aspect is that when you break down a larger application, the smaller part is the business area that you focus on. So it's very subjective when we say small services and things like that. So it needs to be manageable by a small team. That means they need to be loosely coupled from other services, and that is a key important thing when it comes to microservices architecture. So Vivek, so what else can we do with microservice architecture?
Yeah. So let us take an example, Nish. And even in our learn module, we have example which is about pizza shop, right? If you have a pizza shop as a application, just think that this pizza shop is a monolithic application now, and you have a database, and you have bunch of services within the pizza shop. Pizza shop can handle catalog, that means set of pizzas, different pizza categories, and there is inventory of this pizza, and there is order, and there is order management system, could be a payment system, and there is a review system of these pizzas. And if you build this as a whole, right, and take this as a big project, right, big application, and if it is monolithic, it has only one database at the bottom, and at the top you have the application. Just imagine building, making change to just the catalog service, and just making changes into the catalog service. What happens to the whole application when you go and deploy the whole application? So that's where microservice architecture comes into help for you, right? Where you can break this into smaller services, where catalog service as a one service, inventory service as one of the service, order management system or order tracking system as one of the service, where you have different set of services, and each of these services have its own code base, right? And it has its
Mhm.
own code, and maybe we are going to discuss later about different programming language as well, but different code bases. It is managed independently, and as you told, it is loosely coupled. That means the changes you make to catalog service does not affect the changes which is does not affect already running inventory service, or even if you make changes together, it does not affect each other as well. So that's one of the characteristics of the microservice. The other part is deployment. So Nish, throw some light on the deployment side.
Yeah, absolutely. Once you separate the code bases and you have its own CI/CD pipeline, then that means you're just making it clear that you can deploy it independently, right? Once you're loosely coupled, that means you don't have any dependency on another service to complete its feature or something like that. You can always have your own CI/CD pipeline and deploy them into production very easily. And talking about separate code bases, one thing to remember is these are all patterns, but there are situations where you might want to change things, that's also totally okay. I've known people who use monorepo as well, but their CI/CD pipelines are separate. They do monorepo for just simplicity, but the CI/CD pipelines are separate, and that is also important thing to know, that you should have that cadence of a quickly able to release a feature to production or fix a bug to production without really worrying about whether the other microservice needs to complete its task or not, right? So and then so what about data, Vivek? How do we handle data in that case?
Yeah. So as I told you, right, if you had a monolithic application, you would have shared database, and if something happens to database when you're upgrading or something, your whole application is down. And now that means you cannot order if you make a change to something related to review data changes, review service data changes. If you make those changes and the whole application goes down in a monolithic world, and if you are in the microservice world, right, if each of these services are having its own persistent data store, it saves its state of the data, and it is separated, and these data is exchanged between different services via the APIs, not directly talking to a databases. So each service having its own data, and it is maintaining its own state and making changes to its own data store, and it is independent. And maybe you can also use different databases for different services and in various cases, right? So that's one of the thing. And coming talking about communication of these services, Nish, how does it work? How do communication work?
Exactly. So now that you have separate databases and no two services can access each other's database data directly pointing to a database, so they have to actually work with a well-defined APIs. And so that means you define a contract. How does one microservice get the data of the other? That is always through a contract. There's an endpoint. Either you connect with a synchronous endpoint, that is like making a HTTP request or a gRPC request, and then just getting those data that way. Or you can have a completely asynchronous form of communication. Like, for example, you are completing an order, and the order system can raise an event saying, now the payment has to be initiated, and there can be a payment service that's listening to this event, and then it pulls up the payment related event, and then processes that, and then it raises another event for another microservice to call. So that's how they have to be independently working by using well-defined APIs. And also, that's a key thing. Like, so no two service knows how a particular implementation has happened in the other microservice. So that brings up a point that you can have a completely different architecture, or even a different programming model, right, Vivek?
Yes. While I was discussing with you as well, it's fun, by the way, but I'll come to the fun part later. The first part is obviously you can have these different services in different programming languages, maybe libraries and frameworks. Even the databases can be different, as I told you, right? Even the databases for these different services can be different. You could use SQL Server for catalog, and for auto tracking, you could use MongoDB and Cosmos DB and other things. So this is the advantage of the using the microservice architecture pattern, where you have the flexibility of using different programming languages for different set of services. And as a use case, why this is really helpful is because when you're migrating from monolithic to microservice architecture, and if you have a legacy project, legacy applications, and probably you might have built your application in PHP, and you have new set of customer scenarios coming up, and new set of customer scenarios you are designing in .NET, and the services which are there in PHP, you still maintain it in PHP, and probably slowly migrate it to .NET and other required languages if you are looking at different scenarios. So net, you could use different programming languages for different applications, or you could use the same programming languages. The fun part here is, as a developer, if you are if you are in one of the building one of the microservice with Python, and you are interested in moving to .NET, if there is another service team which is actually building something in .NET, you can go to the .NET team and learn .NET and build .NET stuff as well. So within the same organization, within the same application domain, you are actually spending time on different programming languages. So that's the fun part of it, by the way. So and as a developer, I would love to do it, because you're moving towards different programming languages, jumping on different libraries and frameworks, but it is very difficult to manage it.
Yeah, that sounds cool. I was, as you were speaking that, and I was thinking, that sounds cool, that having a different programming languages and things like that. But it's not always easy. It's going to be really difficult as an organization to manage that. But as rightly said by Vivek, if you're using patterns like Strangler pattern, where you're modernizing your application, and you have some legacy systems that you need to, and you still need to continue to keep that as a legacy systems, you can write wrappers around it, and those are the perfect examples of when you can use polyglot programming scenarios in microservices. So, Vivek, before we go further, I have one question from the audience, Ashutosh Khanna on YouTube, asking what points to consider whether microservice approach will fit in that project or not, or microservices architecture, is it applicable everywhere? Do you want to take that one?
Yeah, so if it's very simple, if it is a standalone project, or it's a project where you don't have any upgrade or anything, then it is not a candidate for microservice. But if it is a service, that means you're going to update it. Say, for example, the inventory service, the order management service, the review service, where you have code changes going on very frequently, then you have a couple of services like that within your application. That's the good candidate for microservice. I mean,
Yeah. Also, I want to bring up one thing is, like, it's not answering your second part of the question, which is like, is microservices architecture applicable everywhere? The answer is no. Microservices are, even though it gives this much benefits and advantages that we listed out here, it definitely comes with a complexity, and it also has a cultural change in the organization. You have to start thinking every single service as an app of its own. So that's why it's not always recommended to start with microservice for every single thing. The monolithic applications are still great. They're just a choice between. They're not old or legacy by any means. I know when we speak to customers, they feel that monolithic is kind of old. It's not like that. You can always use technologies, cloud native technologies like Dockers and Kubernetes for even monolithic application. It's just that the architectural design patterns are two different things, and it gives you those benefits. So if you're large organizations looking to spin up features and products, and if you are in a position to maintain that kind of an ecosystem in your organization, then I think microservice is great. It brings in great benefits. But otherwise, yeah, be careful in when you choose a particular architecture. It shouldn't be something which you went for something and you landed up burning your fingers. So that shouldn't be the case. So you need to analyze it. So it's always case to case basis. And also there's one other question from Raju. Doesn't API calls between microservice introduce tight coupling and add to latency? So I'll take that up. Yes. So when you have direct API calls, that definitely has tight coupling, but there are situations where you probably need to, and those are the situations where you need to think about how are you going to do that. For example, in cloud, everything is failing all the time, right? So you have to bake in a resiliency in your service to service calls and things like that. So whenever possible, keep it asynchronous. That's the right approach to do it. But there are situations where you need to do a synchronous call. So it's not like a strict pattern where you say, okay, this is something which you can't do it now. Understand that we do these things to give you that kind of flexibility. So if it's coming in that way of spoiling that flexibility, then I think you shouldn't be doing it. But otherwise, you should be totally okay to do that too. All right. Vivek, so why develop in microservice architecture today?
Yeah. So, let me go back and take the same example, right? So, which is also part of our learn module, which is the pizza shop, and I have a bunch of couple of services, catalog and inventory and order and everything. So now, as a upgrade to your service, you want to add a review service to that, right? And if it is monolithic, as I told you, it's very difficult, it will fail, you have to build it as a whole application. Even your, if you want to just add review, you have to build it as a whole application, and it will take a lot of time. So
Are you guys still there with us? Okay, it looks like we have some technical interruption on Voic's side. So I'll just go ahead. So I was talking about why develop in microservice architecture. Well, I think the big benefit or the big boost that we get right now going with microservices architecture is that we are in a world of cloud where we have that kind of like the ultimate power of the cloud, where you can scale up and scale down a particular service and only pay for a specific services when you need to. So when you have this kind of flexibility, going with this kind of architecture gives you greater benefit. Especially think of scenarios where you have to do a geo replication of your services. You can quickly do that because you already separated the things and then separate the concerns, so you can bring up those services when you want to. Right. All right. Let's go into the next one, which is what role do containers play? And this is an important aspect that I need to answer this right away, because I think often people confuse that writing a Docker container or creating an image out of a Docker container is making a microservice. Absolutely not. Microservices is just an architectural pattern. It does not say that what technologies that you need to use to implement that. But definitely, the advantage you get with containers is that containerization is an approach where you package your application, your dependencies, your configuration all into a single deployable unit. So that way, you can make that deployable unit, send it to production, deploy to testing, and then you get the same, thing out there. So if you tested something, you know that it's going to work on a different environment where you are deploying it, right? So there are different advantages for this, and that's one of the reasons why often people talk about containers alongside when we speak about microservices. So the popularity of microservices and cloud in general have pushed a lot of cloud native technology tools to help you be successful with it. So that's why if you're in 2022 now, when you're starting with cloud native apps or microservices, it's always great to go with Dockers and Kubernetes. All right. So what exactly is a Docker? Then so Docker, I think we talk about containerization, and containerization is a technology that has been there for over a decade now. But I think from the point of Docker, it popularized it. All right, Vivek, welcome back.
Yeah, there's some power issue. I don't know why.
Okay, you sound fine now. So you want to talk about Docker?
So Docker is an open source containerization platform, and it's basically an amazing platform. I mean, obviously, container was there from quite a bit of time, right? And Docker popularized the container technology, and it's basically an amazing platform to build and package your package your applications into images and run it as a containers. And how do you connect between two containers from a network perspective, and also the volume basically from a storage perspective. So it provides you a amazing platform, and it's CLI, powerful CLI, where you can go ahead and execute all these set of commands and manage your build and manage your applications.
Yeah, so one of the things, we were having a nice chat with also Lauren, who's a producer of the show, that this is a good example of resiliency, like microservice resilience. So when Vivek services went down, we continue to operate without really breaking up the entire stream. So that's the advantages that you get when you are in a complete asynchronous side of things. Anyways, jokes apart, so let's go into what exactly is an image. We talk about image a lot. as I mentioned previously, image a container image is nothing but the way you package your application, your configurations, your dependencies, including the operating system dependencies. They're all packaged into a single deployable unit, and then you finally deploy that to a particular server or in your production environment or your dev environment, doesn't matter. And then when this image is running, they're called containers. So in other words, containers are nothing but a running instance of an image. So image, think of image as like something like a zipped unit, which is immutable in nature. You cannot modify that image. You can only recreate that image, provide different version or create the tags for it, but you cannot tamper with that existing image. And that's the guarantee that you get when you test something in your dev environment, your QA environment, and in production environment. You get the same code running everywhere, including the dependencies that it requires. So that way, you can find it like helpful in terms of having application run everywhere as expected, right? So quickly talking about the how does the architecture fit in, right? So just a brief of it. You have the container registry. That's where you store the images, because somewhere you need to store so that the cloud environment can pull it. So you have the Docker Hub or ACR, Azure Container Registry. So you have the Docker client, which creates a Docker pull command, and you pull it from the registry, and you pull the image into the Docker host or anywhere where the container images can run, including Kubernetes. And then when it is run, they have become containers. And when you want to scale, you basically scale these containers. And these environments will automatically create those virtual networks for you, as well as load balancers for you. So that way, even if you're scaled up, it knows which service is operating at certain traffic, and it'll direct traffic to those things. So these cloud native technologies definitely help us boost our application development in a very nice fashion. So
So
more
just
about
to
that.
just to
Mhm.
just to add there, so the images which you create is also stored on the registry. So,
Right.
there could be a private registries, it could be a registries, like the public registries, which is Docker Hub, and then you can also build your own private registries as well. So,
Yeah,
that's
absolutely.
interesting part of the Docker architecture, right?
Yeah, yeah, absolutely. All right. So let's talk about Dockerfile. What exactly is that, Vivek? Then.
Yeah, Dockerfile is basically a set of instructions. So basically, as you told, right, there is image. You create a static representation of your application when you build the Docker, right? When you build the image, when you build your code. So when you create a Docker image, you're just in providing set of instructions for the Docker engine, that this is what the instruction is, and this instruction you execute and create an image for me, create a static representation of my app. So it's very easy to build this Docker file, and you can see most of the commands has been covered in uh, this specific Docker file as well as an example. And usually this is written in a simple minimal language, right? And basically it starts with a base image. And if you see the from command, it starts with a simple base image. And if you notice the microsoft.com.net SDK, which is there as the first instruction, it's a package. It's already a pre-built package which is available on the public registry, which is the repository for having images which is publicly available for you. And you just have to pick that image from the public registry and use it in your Docker file. And this particular Docker file is starting with the Microsoft SDK, the .NET 6 SDK. And you can see there are a couple of other instructions, like creating a working directory, and you're copying the executable, the project, CS project, which is the code base, and then you're restoring it, restoring the dependencies of this project, and then copying the whole set of other required files into this directory from the local system into the container. And then you're publishing the app using the .NET publish command. And the second part of this Docker file is quite different, right? It's basically it is having it is already using the runtime of ASP.NET, and it uses the build which we did, and then it just runs the framework. So this is net net, try to understand, this is just the set of instructions which is available for you, and you build this, you use this set of instructions appropriately and create image, static representation of your application. And this is still static, so it is not running, so this is still image. And when you use with docker run, container run, docker run command, and container runs, and that's when you call it as a container. When something is running, it's called as container, and when is it static, it is called an image. So Dockerfile is used for just creating those images.
Right. So we'll talk about this because we have a hands-on lab on this as well. So we will go through that. Let's talk about why build microservices in .NET. Well, if you'd have noticed the previous few releases of .NET, the performance has been improved a lot, and specifically with .NET Core. Was completely reimagined for the cloud environment. So faster performing SDKs when you use it under the hood, you better you get better at saving the cost on the while running these applications, right? So definitely, if you are new to this, take a look at .NET for your microservices development. All right. So with that, let's get testing the knowledge so far. Whatever we have spoken. So answer your questions. You can. So this is a question: which of the following scenarios would be a candidate to become a microservice? So what you can do is you can chat with us, type in A, B, C, or D. So we will go through this one by one. So that'll give you some time for you to look at it and then give us your answers too. Okay, Vivek. So let's look at this. So the question is, which of the following scenarios would be a candidate to become a microservice? Um, there is a Docker image, then there's GitHub Actions used to deploy a website, and there's a web API. If you're new to web API, that's nothing but a project type in ASP.NET which gives you REST endpoints. So a web API and a website that return and display a list of pizzas, or a web API that returns a list of pizzas.
let me
So
let me let me take a dig at this, okay? So it's definitely not a Docker image, because you can still have a monolithic application in it as a part of the Docker image. And
yeah.
GitHub Actions is more used for deploying an application, so not a building, and it's not an architecture pattern. And web API and website that returns, it's just a statement. It cannot have a website returning. It can only return something, which is an information. So you can't have website returning. So go ahead and go for A, man. It's basically, it's an API. It can only return a specific thing. So basically, you're looking at pizza, and you are just returning list of pizzas which is available through this API.
Right. So I get feedback from my producer saying, so far we have a split on A, B, and C, and nobody selected D. That's a good thing. And A and B, I think there's kind of confusion there, which is understandable and just a nice play of words there. So the correct answer is A, which is a web API that returns a list of pizzas. The reason for that is when you say a microservice, you're looking at just a single thing that is doing one like one business domain and particular actions within that business domain. So we're not trying to club these things together. So that's the reason why the answer A is the right one. All right, great going. Thank you for sending in
And
these
and
options
by
to
the
us.
way, whoever got A, you can just go and buy some pizzas for yourself.
All right, so and let's go quickly on this one too. What purpose does a Docker image have in a microservice architecture pattern? Um, a text file with instructions on how to build a microservice. A Docker image is a static representation of a microservice, its configuration, and its dependencies. Docker images allow hosts to perform load balancing and routing.
Yeah, I mean, that's definitely not a Docker image which is on the load balancing and routing. And as I told you while talking about the Docker file, Docker file is more about text file and instructions, right? And the B is the right answer, because Docker image is a static representation of the microservices. So basically, you're looking at that as an answer.
Absolutely right. That's great. All right. So thank you again for everyone who answered it. So don't forget to go check these out later. So we're going to skip the next question and we'll go straight into some exercises. So you see how we're going to build a Docker file for our microservice, right? So there are
Yep.
answers that you can, there are these questions can be taken up later also so that you can earn your points for that. So don't forget to do that. All right, so let's go ahead and build a Docker file for my microservice. So here is the unit 3. This is where the exercise starts. So the first instruction here is to go ahead and clone the code. So I'm just going to copy this code. So make sure you have Git installed on your system. And I'll just paste it here. And this is going to take a few seconds. And it's going to bring in the code. I'm just going to go into that. And then to just make it easier, I'm going to open this in VS Code. There you go. So I have, so this is a pizza app. It has a backend. It has a front end. Front end is nothing but a simple UI that's going to connect to the backend. So this is typically not exactly a microservices scenario as a whole. It's just two projects, and we are trying to help you understand how you can start creating Dockerfile and using containers, how you can communicate with each other services, right? So let's go back and see what is the instructions that I have here. So what I need to do is I need to create a Docker file. So if I go to backend and if I go into the Docker file, so there is an empty file, right? So just to keep this thing, so that everyone's on the same page, let me just run this for now. I'll just use .NET run. Oops, I need to go to the backend folder and then use .NET run. So don't worry about these things because I'm just only executing just instructions on running it. So now if I click on this URL, it's basically an empty URL. I'm going to go to the Swagger endpoint. By default, it comes with that, right? So now if you see, if you just click on get, click on try it out, execute, it basically nothing but some JSON data that's coming in, right? So this is the controller, pizza info controller. You can use minimal API if you want to, but we just, we were doing this from .NET 5, so we just kept it that way because even in .NET 6, you can continue to use, API controllers for your app. So here it goes. So it's just an info intro controller. There's static data. It is being, rendered back when you make a get call, right? Just a simple one. Now, what we need to do is we need to containerize this application. To containerize this application, what we need to do is you have to add the Docker file. So here is the instructions that Vivek actually mentioned. So I'm going to copy and paste that thing. And so this thing, if you look at what it is doing, is it is going ahead and it is basing it out of SDK because right now, as I mentioned, when you create an image, your image should have the dependencies, including the operating system dependencies. Since you're working on a .NET code, the .NET code requires, where are you running it? So in our case, since we are basing this out of the .NET SDK 6.0, by default, it's going to give you the Linux version of it. You're going to have those SDKs included in your image, right? So all these things are going to be taken care of for you. So it's basically going and doing a .NET restore and creating a publish command so that it will just package into something which you can run, right? And you also have to go and copy the rest of the things as well. So this is called a multi-stage Docker file. What that means is in a Docker scenario, you can continue to build the images, and each instruction that you see here is creates a layer of its own, right? So when you create layers, each of it, so you can go ahead and make changes to independent layers and things like that. So with multi-stage, what we're doing right now is even though we're using this SDK to build, so we're going to copy the code from our local, put it into the Linux environment, compile the code there, but we're not going to use any of the source code that we already pulled into the workdir SRC folder, because we're going to ignore that and we're going to make a fresh build, which will actually say, okay, now copy everything what was built using, which is available in the app folder, take that in, and then build my base image, because while running it, you only need this to run. So if you look at this, the advantage of multi-stage Dockerfile is that you can have those test environments, you can do QA, you can do everything. And in the final from instruction, what you provide is what the base image is going to be. Sorry, what the final image is going to be. So that way you can completely do the QAs and everything going great with that, right? Okay, so that is fantastic. So now I have created the Docker file. Now the Docker needs to know where is my instruction to build the image. So I'll go ahead and copy this code, which is Docker build -t pizza backend, and I will build that. So this time I'll just open again my PowerShell, and I'll just copy that command. I'm just using a Docker build instead of, oh yeah, it says no Docker file. That is because I need to see where I am right now. Okay, page. Let's go ahead and use this. Backend. I need to go into the backend folder and then copy this thing because that's where our Docker file is. And that's why, because we give this context as dot. So it's going to look at this Docker file. And if you look at this one, so it's each instruction, it is going to pick it up and create those layers for you. And then you can see that, everything is being built, and that's it. Now, if I just go ahead and do Docker images command, I have too many images in my system, but at some point you will see that, there was a pizza backend that was built. Let's go up, let's go up, let's go up. Yeah, there you go. So there you go. So there's a pizza backend that I just built 7 seconds ago. And you have those details, right? So that means now the image is being built. Now we can run it. We have the instructions also how to run this application. So we can do the run command here. So I'm just going to copy this, paste it here. And this is nothing but it's saying Docker run in the interactive mode, remove the containers when it is done. And I want to expose 5200. That's the port of the host machine, because now I'm running in my dev environment. But the internal port of that of the Docker container is 80. Remember, we also wrote an instruction called expose 80. So that's what you see here. And then we provide the name of the container and the name of the image. So now it's running on 5200. So I can open a browser, go to localhost 5200, and then use Swagger command. And you can see that, this is now running inside of the Docker Docker containers. So, which is very easy, right? I mean, just write some instructions. Actually, we can make it even more easy. If you have VS Code installed, you can do Control-Shift-P and make sure that you have Docker extension installed, and then you can do add Docker files to workspace, and you can choose the environment, and then you can choose the project, and this will automatically create this thing for you as well. And same tooling support in Visual Studio as well. So it's really easy if you are containerizing your .NET application, because you have some great tooling support. All right, let me just go back to the instructions and see if there's anything else. So I think we're good for now. Let's quickly get back to our slides and talk about. So let's go back and talk about microservices orchestration. Vivek, I think we need to slightly go a little faster on this now, so that we have more time for building the code as well.
Yeah, so it's you need an orchestrator, right? So Nish, so basically, um, if you have 10 containers, and I don't know which container needs to talk to which container, and how do different containers share their storage. So you need to have some kind of orchestrator, and also how do you bring up all these services together, right? And now it's not it's like if you have 10, 15 services, how do you build and deploy it, and also make sure they're orchestrated, they're talking to each other, and how does it works from a network perspective. So if you want to build all those things, you need a simple orchestrator to start with, and we are going to talk about a very amazing orchestrator in the next set of module. But you need a simple orchestrator here for sure, and that is the Docker Composer. So Nish, can you go through the Docker Composer file
Yeah.
as well?
Before I go to that, I think the important aspect to know here is when it comes to orchestrator. So once you create these container images, you will be deploying this to some sort of a cluster where most of the services are going to be running across maybe a single VM or maybe multiple VMs. So you need an orchestrator kind of like manage all those things for you, and that's the infrastructure side of things. So from a dev prof point of view, it's all about just packaging your images and telling the image what packages you need, what dependencies you need, what are the things that you need to run it. That's all the instructions you do. But finally, when you get deployed, you need an orchestrator to take care of a few things for you, which we will go into the details of it a little later. But for this module, what we did is, because there will be multiple services that you will be working with locally, and using a very complex orchestrator may be too much of an overkill, you can continue to use Docker and then use a tool called Docker Compose to run all the images and services together. And that is what Docker Compose tool does. So it's technically not an orchestrator; it's just a tool to help you, create a network for you, create multiple. So you saw that, I just built the pizza backend. We're going to go and build the pizza front end too. So now the pizza front end and backend have to work with each other. That means they need to know where they are running, which is a network. How are they going to send the configuration values to each other? So we use a Docker Compose tool just for this module, but in the later module, we will go into a little more, production-like scenario kind of orchestrator, which is the Kubernetes. Quick thing on the Docker Compose file. So let's go ahead and and talk about the Docker Compose file here. And in case of Docker Compose file, it's nothing but, again, it's a set of instructions for Docker Compose tool to understand what are you trying to do here, right? So the Docker file is just a series of instructions. It's like commands that you write. But the Docker Compose file is a YAML file. So it has extension .yml, where you will write in those things. You basically define it. Okay, what is your service? So in this case, you have a service front end, you have a back end, and then you type in, okay, what does this service front end do? Like what image does it have? And you specify that image that it needs to pull. And then it has few things like port. Remember, when we are running the command like docker run, and we said 5200:80, 5200 was the host port, and the 80 was the internal port. In this case, you are specifying that in a single file so that you can simply go ahead and type Docker Compose and up. It will bring up the entire thing up, right? So let's go ahead and look at how do we take multiple services and run. But before that, I think we have a time for one question. What do you say, Vivek?
Sure, go ahead.
What is one use case for an orchestrator? So is it to scale out and manage complex distributed systems of microservices? Is it to hold the Docker images in source control? Is it to automate security penetration testing? That's an interesting one. So which one do you think?
It's it's definitely not the penetration testing, and orchestrators are more about building, managing the complex distributed systems, for sure. So A will be the right answer. The B one, Docker image and source control. Yes, we're going to have Docker images, but I don't know about having it in source control. But you can have Docker images in the repositories like Docker Hub. So that's something which we can have. But A is the right answer.
Fantastic. And those of you responded to us with A, congratulations. That is the right answer. And let's go quickly on another question, which is also an interesting one. Which language is a Docker Compose file written in? Is it C#? I think so. No? It may be
No.
YAML. It may be JSON.
It's in the background. YAML is the new code. It's in my background.
Yeah, that's true. The new language of the cloud, huh? All right, people. YAML is the right answer too. All right, so one more exercise left in this module, so I'll go quickly do that, is about creating the Docker Compose file. Again, you can see how easy these modules are to execute. As long as you install Docker correctly, you should be able to execute most of the things that is written here. All right, so let's go to the unit 5, which has this Docker Compose file. All that I need to do is go ahead, copy this Docker Compose file, and then go into the Docker Compose YML file. Again, that's an empty file. Just go ahead and Control V. That will save the file. Okay. Now, when I'm going to run this, it is going to run two things. One is the Pizza backend, and it is also going to run the Pizza frontend, because as you saw, we have a backend and we have a frontend. So the front end already has a Docker file. You can see that there is a Docker file, how this has to be built. There is instruction here, so which is good. So it is only going to look at which is a Docker file, which is available for these projects, and then it is going to build that file if that image is not available, right? So in your system, so in my case, Pizza frontend is already available, so it's already built, so it shouldn't take much time. But if it is not built, it is going to go and build that image for you. Now, while running, these instructions come in handy, which are the ports. And so this is where the external port is the host port is exposed. So, for example, backend will run on finance 02, and the front end will run on finance 00. Same thing as when you type docker run and then provide the port with the -p. It's the same thing that you write it here in the YAML file. The interesting thing I wanted to show you here is that now the front end has to connect with the backend. So front end is nothing but a simple UI, and that UI has to connect with the backend. That is the JSON data that you saw that is going to be displayed in a UI. Now that data has to come from somewhere, and that's your backend. So your front end needs to know where exactly is your backend, and that is what you will be providing an environment variable in your in your front end service, saying what is your backend URL. So what you're doing here, you're actually giving the name of the service that you defined here, backend. So when you send this thing into the environment variable, what it's going to do is it is going to inject into the environment side of your application. So when you go into let's see if it's I think it's the startup.cs. When we create the HTTP client, oops, sorry about that. Here you go. So it's creating this HTTP client, which is a pizza client. And here we say configuration.get value backend URL. So now the ASP.NET Core has this built-in configuration helper methods, which will actually pull that value from the environment variable. That's it. And your .NET application doesn't even know whether you're running it in a Docker container or outside. All that it is looking for is the backend URL, that value, right? So that value is actually injected, and that is what we do in the Docker Compose file. So now to run this, I need to be in the root folder. So let me go to mslearn. Yeah, and then instead of using a Docker command, I will be using Docker Compose and up. See, there is no more instructions. Like, we are not providing any more instructions. So what it's doing is it's going and running both the images. So for example, let's say if I do a Docker ps command, and you'll see that there are pizza front end, pizza backend, both of them are running now, and it's running on finance 00 and finance 02. Back front end is running on finance 02. So we can now go open a browser and go to finance 02, and you can see that there is that web page. Internally, it's the Razor pages, which is actually querying the pizza client and then getting that response. So whatever you saw as a JSON value now has a UI to it. Very simple application, but it just clears out two things: how do you build a Docker image, and how do you communicate with other services? So yeah, that's that's about it for this module, and some great references out there for you. So make sure you check that out. And what we did here is just a summary of what we did here is the explain what microservices are in general. We talked about cloud native technologies like Docker, and we also built a microservices endpoint in .NET. So, all right. So
Let's
Vivek,
go to let's go to the next module. My favorite
yes, I
module.
think, yeah, I know you are an expert on Kubernetes. So let's go to the next step, right? So now we have to think about deploying your application or your .NET application into more production-like scenario, like probably Kubernetes, right? So what are the learning objectives, Vivek?
So, in this module, we're going to cover a couple of things. One, we'll try and briefly understand the complex orchestrator. The previous one was a simple orchestrator, but now we're going deep diving into the complex orchestrator, and then we will build the .NET app and deploy it and push it to the Docker Hub, which is a registry, and then we're going to spend some time in terms of deploying this application on Kubernetes, and also we will see a couple of Kubernetes important things like the scale and resilience and other things, right? And this is about the module. And let's go
Cool.
to the next slide. So cool.
So
And you, so go ahead, Nish.
no, I was about to ask you about. So now we are talking about the real orchestrator in picture, and
Yeah.
what exactly is an orchestrator and why we need them. And yeah, let's talk about that.
Yeah. So basically, there are two things. So basically, you have couple of containers, right? So, the pizza shop example which Nish showed, we have a couple of containers there, and you want to dynamically increase this number of containers which is running, just to make sure that your application is scalable, and that is one part of it. And then there is automatic updates. Basically, you are updating different containers. You have 10 different containers, and you are versioning different containers, you are releasing code. And how do you do it? How do you manage it? That's where container orchestrators comes into play. And that's the main goal of using orchestrators. But it also has different set of things like the network and storage and other things as well. So we'll go ahead and just introduce to the content management, which is also the same thing which I just discussed. It is basically about how do you organize it, how do you add it, how do you remove it, and how do you bring up a new set of things as well, right? So just to introduce you to the Kubernetes, it's very a little bit of complex if it is for the first time, if you're seeing this architecture. So Kubernetes is an amazing platform. It's a container orchestrator platform, and it is also and it also abstracts your infrastructure as well. So that's something which it does. And basically it's a declarative tool. So when I say declarative, there are different set of tools. One is imperative and the other is declarative. So when I say imperative means you are giving set of instructions, specific instructions, what needs to be done. Declarative means you are giving
Okay, looks like we are in the same situation again. We lost him. All right, let's talk about Kubernetes until Vivek comes back. So Kubernetes is an orchestrator platform, and it is one of the most popular ones. There are obviously many others out there, and we were talking about the Kubernetes architecture. So Kubernetes has this API server where you say what is your desired state, and that is written as a declarative configuration. So in your configuration, you can say, "This is my container, and I want to have 5 of these containers running." Or this is my image for the container. I want 5 of them. And Kubernetes will look at that, and it will look at the actual state, and it'll look at the desired state, and it'll make sure the actual state and the desired state are equal. That means any point of time, if your application clashes, um, if your application crashes, then you can actually bring it back in by Kubernetes looking at the state itself, and that is very amazing. Every time I see that happen, it is really, really cool. All right, so how does this do? So always Kubernetes has this master node, and also the other nodes are called the worker nodes. And all the worker nodes have this kubelet in it, and kubelet is that simple tool that it queries to understand what is the state of services running on the worker node. So master nodes are the one where Kubernetes actually runs its API server, and it obviously has those control managers, which looks at what pods to run, what is the replications set that you defined, how many services need to be run. So all those things are taken care by the control manager, looking at it and bringing it up. And there's scheduler, and there's also this etcd database, and that's the heart of this entire Kubernetes architecture, where where all whatever configuration you set, that this is the scale you need, this is the number of pods you need, those are all set in the etcd. So that's what it looks at and then maps it. Okay, and it also gives you a lot of virtual like it gives you a virtual network, so it doesn't matter whether your service is running on a VM1, VM2, or VM100. It doesn't matter. It can run on anywhere, and this whole thing is managed automatically by the Kubernetes master node. Welcome back, Vivek, again.
Yeah, I don't know, something wrong today with my power. No issues. No, let's go back to the session.
Yeah, so I kind of like explain the Kubernetes architecture. So you may, if you have anything else to add on to this, we can talk about that, or
Or nothing,
we can go into
just the basic unit of Kubernetes. It's pod
right pods.
and a
Yes.
single any containers you're running. It's either it is single container or multiple containers. It's called pods, and you can see it is run on the worker node here.
Yeah.
So it's available on the worker nodes. So
Yeah.
let's go
One
back
thing.
and let's go into the demo then.
Yeah. Yeah. One
Oh
thing
yeah,
I
you
want
had
to
any
add on that.
questions?
Yeah, I just want to add on to one thing there is it's always confusing if you're a newcomer to understand what we talk about containers and we talk about pods, and then you probably will learn a few things more like services and deployments and different kinds of configuration that you'll define. Well, to understand pods is nothing but a simple abstraction over containers. So containers are just what your Docker host can run it. Um, but pod is another abstraction layer on top of it, to which actually gives that one-on-one mapping. But also, sometimes you can have multiple containers running in a single pod, and that's where something like a sidecar approach and things like that come into play.
Yep.
We will look at that in probably a later session, slightly more advanced than the basic one, right? So just understand pods is just an abstraction layer on top of containers, which
Yeah.
is just the Kubernetes
So it's
language.
it's 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 basically, since we are talking about containers, you have single containers or multiple containers. It is abstracted to as called as pods.
Right.
Cool.
All right. Let's talk
Yes.
about some of the benefits of Kubernetes. See, one of the thing that I like about this is the self-healing technique that I was talking about earlier, which is about the actual state versus the desired state. Because Kubernetes has this, frequent check on whether the actual state and the desired state is equal. Any kind of crashes and things like that, Kubernetes will try and recover things for you. So you don't have to manually intervene and look at what happened. If there were supposed to be 5 replicas of your service and one is down, it'll bring back the fifth one. As long as there is no issue with the Kubernetes master node, it is going to bring that thing back, right? So that's kind of like a very interesting feature of Kubernetes. And the other one is the dynamic scaling, right, Vivek?
Yes. So, interesting, right? When you are scaling your pods in a Kubernetes world, it's nothing but container scaling, but we call it always pods. And whenever you're scaling your applications, whenever you have a lot of requests to your applications, you have to scale that specific service. And that scale part of it, and dynamically scaling it and bringing it down. Say, for example, you might say, I need a maximum of 10 pods running and minimum of 5 running. And when there is a request coming in, the number of pod goes up to the 10. And when the request is less, the number of pods running will be back to 5. And we will see that in an example as well, in how exactly you can set those settings as well.
Right, right, and a few things like rolling updates, managing storage. It manages the network traffic, as I mentioned. It creates a virtual network, so internal services can access, regardless of where your service is running and whichever virtual machine it's running. It always has that virtual network, so you can access them through a simple DNS query. Right. All right. So with that, let's go to a quick set of questions again. So the question is, why is a container orchestrator useful in a microservice architecture? All right, people, send in your answers. Is it A, B, or C? A is each microservice needs to be maintained, scaled, and deployed individually. An orchestrator helps manage those tasks. An orchestrator holds instructions on how to build and version Docker image. And C, an orchestrator is the only means by which to run a containerized application in the cloud. So which of it is true?
Is it A? It should be A,
It should be,
isn't
right?
it? Yeah.
Yeah. So an orchestrator is the only means by which to run a container application in the cloud is absolutely no. You can run it without an orchestrator. There are a number of cloud vendors providing you different ways to do it. Um, an orchestrator holds instructions on how to build. Obviously not. The orchestrator doesn't know anything about how you build your image. So obviously it's going to be the A. And thank you so much for sending in all your answers. And everyone has said A. So that is amazing. All right, so that is the right answer. And Vivek, let's go ahead, share your screen, and we will talk about, uh, deploying the Kubernetes, deploying the .NET application to Kubernetes.
Yeah, and this is the learn module, which I'm going to use in this in this example as well. And There are a couple of settings. You need to have a Docker desktop here installed, and you see here you should have a Docker Hub account. And we are taking the same example, the pizza shop, which Nish was using, and the repository is here. And I've just cloned the repository, just in case we run out of time. Right, we are just clone it. So you can just copy this instruction and clone your repository, and the code will be downloaded. And then we did this already, right? Nish did build and bring up the composer, the Docker compose file. So basically he's bringing up the complete application. So let's build it. So I've already done the build. So once you do the build, uh, it's here. The you know Basically the image is being created. So I've just used the same command. So just few minutes back, I've run the same command. So let us bring this up in the background mode though. So I'm just bringing it up just to show you what it does. So I have this in the Docker uh, compose, right? So it's just running a simple service which we have already executed before. I haven't done anything related to Kubernetes yet. So this is the application which Nish had brought it up. Right now, what we have to do is, so we have to go back to the so we need to sign into our Docker Hub account, right? So this is the Docker Hub.
Yeah, so while you do that, I'll just quickly explain. Docker Hub is nothing but a container registry. So once you create the image, your Kubernetes environment or wherever you are pulling in your image should know where to pull this information, pull the image from. And we're using the Docker Hub. You can use any container registry for that matter. And Docker Hub is free for your learning and development and things like that. So yeah, it just makes it easy for you to get started because you already have the Docker tool
Yeah.
installed, so it's easier to do that as well.
So this is a public repository as well. So anything you get started with, if you just type in anything, and if you don't have the image within your local system, uh, the Docker command searches in the Docker Hub first, and that's the main purpose of it. And these are all my my images. I've created these images quite a long back, and this is the repository, right? So now I have an account, I have everything ready, and I need to do a tagging. So what is tag is basically what you're doing is, you're tagging the already built image to reference it to the Docker Hub, right? Here, the image which we had built, so for example this one, these two image, it's local as of now. I want to make sure this two image is tagged to the Docker Hub. So we're going to go back and tag that up. So let's go and execute this command here, and put the Docker name, right? I've done that now, and I've tagged it. I can go and tag the other one as well. So I just putting my ID. You see your Docker username. So let's put that username. That's my username there. Just bring it, and then you have to just push this image, the tagged image, to the Docker Hub. So it's pretty easy and it's very straightforward. We'll go here and just push it. So Docker push and image name. So let's take that. Okay, let's first run the tag, right? Let's see the tags which has been created. So you can see here tag has been created. There were two, there are four now, and we will go back here and Docker push. We will push these front end to my Docker Hub account. and then we will push the backend. So let's give it a minute to push it.
So you're pushing the front end first, or did you push the back end too?
The front end first.
Okay, cool. Yeah, I wanted to. So that once you push this front end first, and then when you push the back end, you'll see how fast the Docker does on the second one because it uses the cached layers. And it's a very interesting way how it does it. So that way, it just makes it easy for, your storage and things like that too.
Oops. Yep. Sorry. So let me push the other one backend. This will be fast.
Yeah. So it says preparing. Um,
Okay. So this is great. So while this is going, let me go to the run module. So it's basically, you're pushed it, everything is up there. We'll go to the next unit and we're going to deploy the application, right? So basically, if you see my Docker account now, the Docker Hub account now, uh, what you will see is at least the front end will be here if the back end is not here yet, or both of them are
should
here.
be.
So if both
Yeah.
of them are here, right, so it's pretty fast. So we are here, and let me go to the next exercise, and let's run and deploy to the Kubernetes. So here you need to make sure that your Docker desktop is set properly for usage. So how do you do that? How do you verify that? So let me go here to my terminal. I have kubectl, which is the client, Kubernetes client, where it is talking to the API server. So I'm going to make sure that my config is right. Get context. So if you see here, my context is set to Docker desktop. So I'm using the Docker desktop context. I have other context, which is on Azure Kubernetes service, but right now I'm going to use Docker desktop, right? And
Yeah.
you can
Just to be
also
clear.
enable, yeah, you can also enable it here if you have
Correct.
installed
Yeah.
Docker. Yeah, if you have Docker desktop installed, you just go to the Kubernetes and just enable it, and it's up and running. And you could see this as well, right? In some of my images here is built. Sorry. Oh, I'm pretty
Fluffy
fast, huh?
fingers.
Yep. So here is the images. If you see here, these are all Kubernetes images, right? So that's what it is. So anyways, this is done. So I have Kubernetes running and everything, and I just need to create a set of instructions for Kubernetes to run. So I'll just open this code. Where is this code? Am I in code? Yes, I'm in the code. So let me go here and open it in my VS Code and create. Okay, my VS Code is in the other system. Let me push this out. Let me bring it up here.
Yeah, just click on the trust one.
Yeah. So let me create new file and create a YAML. So this is backend YAML I'm creating, as we told you, right? So YAML is the new code, right? So this is the instructions which you're providing for communities to get started. So this is having a couple of things. I'm running through a deployment kind, which is a deployment controller, and have it has three specifications, right? The API, the metadata, which you have to specify with the spec, and you can notice this is the replica, that is only one pod which is having one container will run, and here is the container details. So you can see here the container details is my Docker hub account details, right? The Docker username, the Docker hub account username, and here you are setting a couple of things, which is respect to the environment, and then you're creating a service. This is service to the access the deployment kind, the service which you're going to deploy, which is pizza backend, and this is accessible via cluster API, which is not part of exposed, right? And we will see another service on the front end. Since this is back end, it should not be exposed. The front end should be exposed, and that will be built on the load balancer. So let's go back here and update this code, and just update my ID here, and just save this, and we are done with this. And now we go back and create for we did create for backend
Yeah, you did that.
deploy. Yes, we have to do it for the front end. Let's do it for the front end as well. And then, so front end as well is the same code, right? There is nothing much changes. Everything is the same, but the environment is changing because it is referencing the is a backend code, and that is what it means. In the same thing we are doing with the deployment kind, with the pizza front end, and then there is the service kind, which is to access this particular pod, and that is through load balancer. So that is pretty simple and that is pretty straightforward. So we just copy this and go back here and just convert this into, wait, save it. We have done the saving. Everything is ready for us to go and execute now. So all we need to do is just apply backend and front end. So here it's a simple Kubernetes command, right? So let's go back and apply. So we have applied this, and then we go and apply
Front end.
front end deploy, and we have applied, and we will see kubectl get pods. You will see the pods are running, and these pods are running in the local, right? So when I go to the local host, and if you see, uh, I go into the local host here. If you see here in the learn module as well, we will see the application running. So this one is running through my Docker Compose app, which is on the Docker side, with together built as a one single unit, all the containers built as one single unit. And here it is running on Kubernetes, which is a complicated orchestrator with other set of things which you can enable on this, right? So now we are running this in terms of Kubernetes, right? But we will see different scenarios where in the next exercise we'll see how we can scale it, how we can bring it down and other things. So we will see how you can do the replications. So now kubectl get pods, you have this many number of pods, and we will deploy 5 replications. That means 5 different pods gets created for the backend service. So you can see here it is creating 5 different services. I'll not wait for it to keep running. It will start in few seconds, and let me see that, make sure that we can also scale it down when there is not much traffic. You can also scale it down. So let's go back and scale it down as well. So we just need to put the replica back to 1, and it is scaling it down, right? So let's see, it is already scaled down. So that's how you can scale up and scale down in Kubernetes, and you can set these up in the deployment file itself. And the reason why we are using deployment is because we are, as a whole, we are applying it to the complete deployment kind. So that's the reason why we are using a deployment here. And just to prove how exactly this works in terms of resilience, basically if you go and delete something, and how exactly this works from a delete perspective, you delete a pod and it will get recreated. So just notice this, it's running, basically, if you see here, it's running from 2 minutes as of now. And we'll go here and just delete it. Kubectl delete pod. Sorry, let's get pod first. Pods kubectl delete pod
Yeah.
will
So
take
you can also notice the name. It has those random
yeah
values there.
different names.
So
Yeah.
yeah, we delete the pods. I mean, he's trying to reproduce a scenario where it probably has crashed or something. So what
Yes.
does Kubernetes do if some pod, has a crash, right? So in production, you will never go and delete pods like this. Uh, it's just to show you how to
So
do this.
here you notice that I deleted this pod. That means something happened on the pod and it recreated. And basically this, if you notice the name change here, so that's
Yeah.
the difference. So that's what resilience is all about. So Kubernetes is such an amazing orchestrator that you can scale it, and also if something happens, it will automatically bring those changes back. So the beauty of this is you have provided the the instructions via the YAML file, which is what we did here. So we did tell that we need only one replication, so we could have said we need three replications, and it will make sure that those three replications is maintained. And you can also say maximum replications, like whenever there is a lot of traffic, you can scale up to 10 replications and other things. So these are all settings you can provide in the YAML file, and that's what the module is also all about. So Nish,
Awesome.
we will
Yeah.
do the knowledge
So
check.
so we'll just bring back our screen and my screen, and then we can go on the next. So that was really really easy. We looked at two modules. We clubbed it together because it always made sense to do it together. We created on the first. We basically went in as a developer. We created a Docker file and then containerized it, and then the second one we actually deployed it to Kubernetes as well, so which is awesome. All right, so let's go into the last knowledge check, which is, why does Kubernetes automatically restart pods that have failed? uh, let's go in and read out these things. A, Kubernetes will maintain the system state as defined in the configuration file no matter what. B, Kubernetes will maintain the current system state as is when a failure occurs. Kubernetes will not automatically recover. Rather, it needs to be told to. Um, yeah, if Kubernetes was a person, maybe the C would have been the right thing. Uh,
Yeah,
and
as I told you, right, it's all about configurations. So it just makes sure whatever user has given as a configurations, it's just take that configuration and it just makes sure that it takes care of that configuration, right? So that's the good part of Kubernetes. It's a very good friend of us. You just tell it, this is what we want, and it just takes that information and just goes ahead and make sure it gives you all the help.
yeah, so always remember the desired state versus the actual state.
Actual state.
That's the
Yeah.
key thing. So your desired state is what you write in your configuration. That's the declarative configuration. Uh, all right. So just to summarize, what we looked at right now is we learned the concepts behind orchestrators. We took an existing .NET microservice hosted on a Docker container and pushed it to Docker Hub. And then we deployed the microservice to Docker Hub to a local Kubernetes instance. Now, the reason there are many ways you can deploy to Kubernetes. If you're adventurous, try it out on a real cloud, like Azure Kubernetes Service. The YAML files are all same as long as the context is correctly written. You will be able to deploy with the same YAML script that you wrote. But we wanted to show you really easily to do it because Docker Desktop also comes with the Kubernetes, so it's easier to enable that. You can use other instances like Minikube for it as well. And we also learned how to scale a container instance in Kubernetes cluster. So basically, the way Vivek showed was writing a scale command, but you would probably write a scale replica set in your YAML file and configure it that way. Okay, and there's some great references out there. Please check it out. I have done an entire video of this in a nutshell on what microservices are and then connected all of it. So don't forget to check that out too. And also we have some great ebooks and reference samples that'll help you build microservices, not just the Dockers and containers, but also understanding domain-driven design and how multiple services can work together and things like that. So there's great documentation out there. Um, all right. So we learned about building your microservice with .NET and deploying .NET microservice to Kubernetes. So those are your links Don't forget to try them out. They're really, really simple ones, and then earn your points. And before we sign off, we wanted to let you know that don't miss out on some amazing sessions that are lined up for you on the microservices side of things. Every Tuesday, same time, we're going to do some really advanced to intermediate to advanced topics. And the next one being create and deploy a cloud native ASP.NET Core microservice, where we will look at an entire e-commerce application. And ideally, the best way to learn microservice is not about like file new project, but to understand, okay, what is my infrastructure right now, and what is the feature that I want to develop, and is it a new microservice that I need to develop? Then you go ahead and build a new microservice, add it to an existing cluster, and we will do that completely on an Azure Kubernetes service, entirely on a browser. And that's the funny part, because we will not be using any local machine. We will execute everything on an Azure CLI, and we'll go into much more in depth, like how do you implement health checks and things like that in ASP.NET. All right, so don't forget to check that out. We have some great sessions lined up every Tuesday, same time. See you in the next.
See you.